when an electron is being removed from an atom, energy is required. Why? Energy is required because the electron is firmly attracted by the proton. The positive proton attracts the electron, the outermost electron. So to remove an electron from the outermost energy level of an atom, you require energy. This energy that is required to remove an electron from the outermost energy level of an atom is called ionization energy. And the electron is removed when the atom is in gaseous state. The electron is removed when the atom is in gaseous state. Now, the first electron, when it is being removed, the energy required to remove the first electron from the atom in gaseous state is called first ionization energy. And when the first electron is removed, the ion is going to be positively charged and it will have a charge of +1. It will have a charge of +1. When the second electron is being removed from this ion, this one is going to be called second ionization energy. And second ionization energy is removed from an ion with a +1 charge. When the second electron has been removed, this atom is going to have a charge of 2 positive. Then when you remove the third electron, you require the third ionization energy, and the third ionization energy is removed from an ion with a +2 charge. Now, the first ionization energy is usually less than the second ionization energy. The second ionization energy is greater, the way you can see from the table. Why? Because after you remove the first electron, this atom, the electrons that remained are going to be pulled more by the proton, because the proton, the nuclear charge, is pulling the electrons more strongly. So you require more energy to remove the second electron. You require more energy to remove the second electron. And the third ionization energy is even higher, because as you remove electrons, the ones that remain behind are attracted strongly to the nucleus. They are attracted strongly to the nucleus. Let us continue. Now, this diagram here shows how the ionization energy decreases or increases in. It shows how ionization energy decreases or increases in atoms and ions, in ions and atoms. First ionization energy versus atomic number. As you move down the group from the diagram, you say, helium is on top, followed by neon, argon, krypton, and xenon in the noble gases.
Mr.
Yes.
Mr. What is this?
Yes?
What is this 1,500?
This one is a table. It's a table or a graph. It shows, it's a table or graph. It shows atomic number versus ionization energy. First ionization energy is on the y-axis, and atomic number is on the x-axis. So when the atomic number increases, when the atomic numbers becomes more, you can see ionization energy becomes small. For example, the first element, helium, if I look on the y-axis, the ionization energy is very high. It is next to 2,500. And if I look on the x-axis, the atomic number is small. So it means that when the atomic number is small, the ionization energy is high. The second one is neon. The atomic number has increased. It is 10. The atomic number is 10. And ionization energy has gone below the first one. The third one is argon. The atomic number is 20, and the ionization energy has gone below 2,000. So this graph shows that when the atomic number increases, becomes big, when you have more atomic number, the ionization energy goes down. Why is this one possible? This one is because when the atomic number increases, we saw this, When the atomic number increases, the number of energy level in the atoms also increases. When the energy levels in the atoms increases, the atomic radius become bigger. When the atomic radius becomes bigger, the force of attraction in the center of the nucleus of an atom becomes weak. When the nuclear pole becomes weak, it is easy to lose an electron. When the nuclear pole, the nuclear force of attraction becomes weaker, this element or this atom easily loses an electron. And because it is easy to lose an electron, it means you require less energy to remove that electron. That is why the first ionization energy goes down as the atomic number increases. Yusuf Majdi, do you understand that?
Yes, yes.
Very good. And for the lithium, sodium, potassium, and rubidium and cesium, the elements in yellow, all these elements are in group 1, and lithium is the smallest in this group, and cesium is the biggest in this group. Now, cesium is the biggest. It means it has a big atomic radius. And because it has a big atomic radius, the nuclear force of attraction is very weak in cesium. The nuclear force of attraction is very weak in cesium. And in lithium, the lithium has a very small atomic radius. Because it has a small atomic radius, the nuclear pull or nuclear force of attraction is very strong. And because in lithium it is very strong, you can see the first ionization energy of lithium is 500 because of the small atomic radius, which means the pull of the nucleus is very strong. Now in cesium, the ionization energy is below 500. It is very low. Why? Because cesium has a big atomic radius. The big atomic radius makes the nuclear force of attraction to be weak. So cesium easily loses an electron. It uses less energy to lose an electron. And the lithium uses more energy to lose an electron. You understand now the graph? Yusuf Majid, do you understand?
Yes.
Very good.
Thank
Now
you.
let's look at, this one is what we are discussing. Can one person read this, Yusuf Majid? Group trends in ionization energy.
Group trends in ionization energy. Figure 6.17 is a graph of first ionization energy versus atomic number. Each red dot represents the data for one element. Look at the data for the noble gases and the alkali metals in general. First, I would then
Ionization energy.
second water. In general, first ionization energy decreases from the top to the bottom. Within a go. What is this?
In general, first ionization energy decreases from top. Recall that.
Recall that
Within a group.
within a group. Recall that the atomic size increases and the atomic number increases. Within a group, as a smaller effect on the electrons at the highest occupied energy level. So less energy required to move an electron from the energy level, and the first ionization energy is lower.
Okay.
Yes, periodic terms and ionization energy in general first. Did I read this? لا لا. In general, the first ionization energy of
Representatives.
representatives
Elements.
elements tends to increase from the left to the right across a period. This trend can be explained by the nuclear charge, which increased, and the shielding effect, which remain constant. The nuclear charge increase across the period, but the shielding effect remain constant. So there is an increasing in the attraction of nucleus for an electron. What is this?
For an electron. Thus,
What is that?
Because of that, as a result,
It takes more energy to remove an electron from an atom. Figure 6.18 summarize the group and period trends for first ionization energy.
So this one, across the period from left to right, the energy required to remove an electron increases. So when you go towards the right, you require more energy to remove an electron. Why? Because the nuclear charge, as you move from left to right, becomes stronger. When the nuclear charge becomes stronger, you need more energy to remove an electron. And because you need more energy to remove an electron, ionization energy increases from left to right. Going downwards, the atomic size increases. When the atomic size increases, it means the nuclear pull or nuclear charge decreases down the group. When the nuclear charge decreases down the group, you need less energy as you go down the group to remove an electron from the atom. Because you need less energy as you go down the group, it means the first ionization energy generally decreases down the group. That is our explanation from that chart. Yes.
Oh, I think class finished now.
Now we have 10 minutes. Yusuf Yahya
Oh.
على سيري.
Oh, okay.
عندنا 10 دقائق. Okay.
حركات مستر.
So this one also, this table here, it shows atomic and ionic radii are an indication of the relative size of atoms of ions. Now, when you compare the atomic radius and the ionic radius of an element, if the element forms cations, it means this element has lost electrons.
Mr.
Because
what is cation?
a cation is a positively charged ion. A positively charged ion is formed when an element loses electrons. Okay?
And the negative charge is an ion, صح?
An ion. A negatively charged ion is called an anion. It is formed when an element gains electrons.
Yes, lose
Okay?
proton. Yes, thank you.
Okay. Now, for the cation, because the element has lost electrons, it has become positively charged. The few electrons that remain are going to be attracted more to the nucleus, okay? Because now you have less electrons. Because of this, when you compare the ion, the cation, from the atom where it came from, the atomic radius is more than the ionic radius. The atomic radius is more than the ionic radius. For the anion is formed when an element gains electrons. So it will have more electrons. Because of this, the nuclear charge is going to be less when the ion is formed compared to the atom where the ion was formed, or where the ion comes from. So because of this, an anion, the ionic radius of an anion will be more than the atomic radius of the same ion. Yani when an ion before it forms when an atom before it forms an anion, it will have a less radius. When it is an ion, the ion will have more radius, bigger radius. The ion will have a bigger size or a bigger radius. Let us continue from there. Trends in ionic size. Let's have another person read that. Who's this? Let me, Basil. Basil? Do you have Basil? Basil is there? Basil is absent? Anmar Halawan is there? Anmar Halawan is there? Anmar is absent? Okay. Bashir Khoja is there? Bashir Khoja is there?
Yes, mister.
Can you read the trends in ionic size?
What?
Trends in ionic size. Can you see my screen?
Yes, I can see.
Okay, can you read from there?
Okay. Start.
Trends in ionic size.
Trends in ionic size. During reaction between metals and non-metals, metals as atom tends to lose electrons and non-metal atoms tend to gain electrons. The transfer has predictable effects on the size of the ions that form. Cation are always smaller than the atoms from which they form. Anonius are always larger than the atoms from which they form. Complete?
Yes, continue.
Figure 6 compares the relative size of the atoms and ions for three metals in group 1A. For each of these elements, the ion is much smaller than the atom. For example, the radius of sodium ion 95 pm is about half the radius of the sodium atom 191 pm. When a sodium atom loses electron, the attraction between the remaining electron and the nucleus is increased. The electron are drawn. The
Are drawn
electron are
closer.
drawn closer to the nucleus.
Also,
Also, matter that are representative elements tend to lose all their outermost electron during in ionization. So the ion has one fewer occupied energy level.
okay, thank you. Thank you very much, Bashir Hoja. Now, this is the diagram that shows ionic size. As you go from left to right, the ionic size decreases. Why does the ionic size decrease? Because nuclear charge increases from left to right. When the nuclear charge increases, the ions become smaller. And as you go down the group, the ionic size or ionic radius increases. Why? Because when you go down the group, the nuclear charge decreases. Why does it decrease? Because of shielding effect. As you go down the group, the number of energy level increases. But when you go across a period, electrons, the number of energy levels across a period are the same from the left to the right. But from the top to the bottom, the energy levels increase. That is why from top to bottom, the size of the ion increases, but from left to right across the period, the size of the ion decreases. Now, the last part is trends in electronegativity. Electronegativity is the ability of an atom of an element to attract electrons when the atom is in a compound. Now, this electronegativity is also affected by the size of the atom. When the atom is small, the electronegativity will be very strong. It will strongly attract electrons from another atom because of the nuclear force of attraction. The nuclear charge will be strong. When the atom is big, the nuclear charge will be weak. So it will attract electrons weakly. It will be weak in attracting electrons. So in general, electronegativity values decrease from top to bottom within a group. We have said the reason. For representative elements, the values tend to increase from left to right across a period. So across the period, electronegativity increases. Why? Because across the period, the size of the atom decreases because of nuclear charge increases. And down the group, the electronegativity is going to reduce or decrease. Why? Because the size of the atom increases down the group and nuclear charge decreases. Are we together? Did you understand that? Did you understand that?
Yes, yes.
Very good. I think that is it. From this table, you can see what happens. This one gives you a summary. When you go from left to right, atomic size decreases. Ionization energy increases. Electronegativity increases. Nuclear charge increases. Shielding is constant. Shielding does not change. And when you go down, atomic size increases. Ionic size increase. Ionization energy decreases. Electronegativity decreases. Nuclear charge increases and shielding increases. Yes?
What is shielding? Shielding means how much the outer shell can handle.
Shielding, when I say to shield in a football, do you watch football, Yusuf Majid?
Yes, the fact.
What is shielding in football is means to to prevent somebody from passing you in football, okay?
Yes.
Now look at this picture. Let me see, where is my picture?
I know football. I know Cristiano.
You know Christian. Okay, now I just want to show you shielding. Just give me a minute.
Picture the class ended.
I just want to explain this. Just the 1 minute I want to explain
teacher,
this.
are you gonna send us the revision worksheet?
Yeah, Faris.
I sent the worksheet.
I can't see them. Can you resend them?
Okay, I will try to. You remind me. I will send it again. Okay.
And can you also do a revision?
Okay. Yes. From tomorrow, inshallah. Now look.
Tomorrow.
Now look this.
Mr. Please.
الخرس يا يوسف.
Okay. Now look at this, Yusuf Majdi. This is lithium, Yusuf Majdi.
Yes.
Mr. The session finish. I must
يا
go
أخي
now.
الله يحفظكم واحد وأخي دقيقة.
Mr. Can we go out?
No, I have not taken your roll call. Let me take your roll call first, and then I'll remain with the Yusuf Majdi.
What?
Okay.
This is 10B. Let me take the roll call first.
What you say? المهم please.
Ali Sihli is there?
Ali Sihli not with
Another
us.
class.
No.
This is A.
This
Or
is
B.
B
B now.
10B.
This is B. Okay. Just a minute.
Samina.
Anmar Halwani. Anmar Halwani is absent. Basil Saleh.
موجود
Anmar here.
موجود.
Anmar Mawjud. Basil Saleh.
موجود.
He's also here.
I cannot hear him.
والله موجود ها بس.
Bashir is raising his hand.
Bashir Ahmed Khoja. Bashir
here. يلا goodbye Mr.
Khalid Walid.
Khalid Al-Amudi was
Absent. Saif
Yeah,
Al-Dubasi.
He's here.
I am here, Mister. I'm here. Safe.
Okay. Saif Yusuf Al-Dubasi.
Yes, here. Khalid is here.
Okay. Abdurrahman Khalid Zakaria.
مجدي يا دبة.
مين
Zakaria.
Abdurrahman Khalid Zakaria.
Mister, can I go?
خالد.
لباسي.
هلا
يا أخي.
Abdurrahman is absent.
افتح.
No, he's here. He said he's here.
هلا يوسف وشو؟
Can you keep quiet so that I can check the attendance, please?
No.
Abdullah Turki Batarfi.
مجدي يا سبك. هير يا مستر هير. خلي هذا برايفت.
Abdul Malik Falimban.
Teacher Abdul Malik Filimban go to the bathroom. He sent to me that if you take the attendance that he is here.
Faris Ahmed Fathi.
Here.
Faris Khalid Al-Jahdali.
نطلع ولا ايه؟ وش نسوي؟
اطلع ولا
لا استنى لازم ينادي اسمك بعدين.
Is absent. Faisal Abdullah Mubarak Balatif.
فيصل عبد الله مبارك. انا مين هذا جكير.
Muhammad Ibrahim.
يا اخي
here.
Okay, Muhammad Faris, Muhammad Jeffrey.
He's here.
Teacher can
Jeffrey,
leave.
where is Jeffrey?
He's here.
Where?
He doesn't have mic.
Mu'tasim Jalal.
Here.
هي موجود.
Nawaf Rabi.
Here Nawaf teacher.
Yusuf Saleh Al-Amudi.
Here.
Yusuf Majd Amir.
Yes, Mr.
Yusuf Yahya Muhammad Al-Asiri.
Yeah.
He's here.
Okay, so can I
حضرني يا عيال ولا؟
ايوه
بس teacher Basil is here.
Now Yusuf Majd, can you see my screen?
Okay, يلا مع السلامة.
Can you see my screen,
Mr.
Yusuf
Combo.
Majd?
That's
Yes.
finished teacher.
Mister.
Hey teacher time's up. والله time's up.
Okay.
هو بيقعد مع يوسف.
I'm just explaining something. Yes.
احنا نمشي.
Combo.
Yes.
Mister.
Yes.
Basil Al-Amudi is here, huh?
Basil Al-Amudi, okay.
That's such a finished teacher. We go.
يا نواف احنا كنا
Can you give me 2 minutes? I explain this. Can you give me 2 minutes? 2 minutes I explain this to Yusuf. You're making noise. You're wasting the time, and I just want 2 minutes.
No.
I just want 2 minutes.
No.
Now check. Yusuf Majdi.
Yes.
This is lithium. Yusuf Majdi.
Yes.
It has 2 energy levels, okay?
Teacher, can I leave?
When you go down, wait a minute,
teacher.
Teacher,
Balatif.
can I leave?
Our time,
Sodium,
teacher.
when you see
is
sodium,
This
No,
our
but-
time, teacher, please.
I said 2
Yeah,
minutes, I
Nawaf.
said 2
Yes.
minutes.
This our
No.
time, please.
This is the first energy level of
No.
sodium. The second energy
No,
level of
how?
sodium.
This our time,
بدأت
teacher.
again بدأت again.
And the
أيوه.
third energy level of sodium, okay? So that is
teacher
sodium.
خلاص بدأت قامة teacher لما نطلع.
The first energy level of sodium has got 2 electrons.
ثاني
And the
شباب،
second energy level sodium has got 8 electrons.
صحيح صحيح
8 electrons. And the third energy level of sodium has got 1 electron.
في باسل في أنمار حلواني في
Now look at this, Yusuf Majdi.
Yes, with you.
Yusuf Majdi. Lithium to sodium, when you go down, this outermost electron in sodium is close to the nucleus. Are you seeing that?
Yes, I see.
But this sodium, the outermost electron is further away from the nucleus. Why? It is shielded with other energy levels. In between, you have more energy levels in sodium. Are you seeing that?
Yes, I'm seeing.
That is what we call shielding effect. Because of this shielding effect,
This is shielding, صح?
yeah, that is shielding, yes. Because of that shielding effect, the electron in sodium is not strongly attracted to the nucleus, but the electron in lithium is strongly attracted to the nucleus, okay?
Oh.
Now,
okay,
because
okay.
of that, sodium can easily lose an electron.
Yes.
And because of that, the ionization energy in sodium will be low. In lithium, this electron, outermost electron, is strongly attracted to the nucleus. Because of that, you require more energy to remove it. So it is difficult to remove an electron in lithium. So lithium will have a higher ionization energy because ionization energy is the energy required to remove an electron from an atom. Okay?
Yes.
You understand now?
Well, I understand. جزاك الله خير. Thank you, Mr.
حياكم الله جميعا.
حبيبي. Thank you. Can I leave?
Okay, now we can leave. Okay.
Thank you. يلا مع السلامة شباب. محمد الجفري، باسل العمودي، عبد الملك فيلم بيل.